So we're going to do an example now where we estimate the area of an exponential curve. So we're going to look at the curve y equals e to the x plus 1. And we're going to do so on the interval where x is from 0 to 2 on this closed interval. We are going to use a midpoint estimate here, and we're going to break it into 4 subintervals. So something that might be really important for us to do first would be to consider what the graph looks like. So I'm going to draw this in here. An exponential curve shifted up 1. Normally the y-intercept is at 0, 1, but now it is at 0, 2. So we've got 0, 2 here. And we're looking on this on the interval from 0 to 2. And if our interval is 2 units wide, divided by 4 intervals, so then each interval will be 1/2 unit wide. So taking 0 to 2 and dividing that into half and then half again, I have 1/2, 1, and 3/2 here, okay? And we want to use a midpoint on each of these intervals. So my midpoint is going to be calculated by that value in the middle. And you cut a half in half, and this is going to be, we've got 1/4, 3/4, 5/4, and 7/4. So that is my midpoint. And now I'm going to make 4 rectangles. So my first rectangle is going to have a height that would be the output there. It's going to be that middle high. So this rectangle is going to look roughly like this. And that output, if I plug 1/4 into my function, and remember the function that we're using is y equals e to the x plus 1. If I plug 1/4 into that, my output is the 4th root of e plus 1. And that's a exact value. The approximate value is about 2.284. Okay? But for the sake of this, I'm just going to write f of 1/4. So if we just wanted to state the area of this red rectangle, that area would be the width. The width there is 1/2, right? It's 1/2 units wide, times the height, which is f of 1/4. So remember, length times width gives us the area. And that rectangle is not 1/4 wide. 1/4 is at the center of the 1/2 unit wide interval. So that's where the 1/2 is coming from. All right, I can continue this process. I could make another rectangle. So if I go up to my midpoint at 3/4, there's a point there. And if I look at making that rectangle, you see part of it's above and part of it is below. So adding that rectangle, we would have 1/2 wide times f of, and we are evaluating, our height is coming from the y value, so evaluating that function at 3/4. All right, so adding another rectangle. So going up at 5/4, finding the height on my curve, and then making a horizontal bar go straight across. I have another rectangle. In this case, this rectangle here is still 1/2 unit wide, and my height is coming from the output or the y value. In that case, that would be f of 5/4. And our last rectangle here, I'll draw up to the center, make a rectangle go straight across, so we're going down now. And this rectangle is also 1/2 unit wide. And then my height coming from my y value would be f of 7/4. So the only way this would change if we had done lower or upper bound rectangles for our sum of areas is that these outputs, these y values, would be different depending on where we were going up. So I could have had, 0, 1/2, 1, and 3/2 as those y values that I used. Okay, so let's calculate this area. And in this situation, I'll notice that all of my terms have a 1/2 in front of them. So we could factor that 1/2 out, and then I could write this as f of 1/4 plus f of 3/4 plus f of 5/4 plus f of 7/4. So we're going to have 1/2 the width of the interval times the sum of all the heights. And the heights are determined by our lower or upper or middle endpoints. So now this is just busy work in my opinion. But remember, we're evaluating the function y equals e to the x plus 1. So I have 1/2. If I plug in 1/4, I have e to the 1/4 plus 1 plus e to the 3/4 plus 1 plus e to the 5/4 plus 1, and finally plus e to the 7/4 plus 1. And just for the sake of tidying this up, that's the same as e to the 1/4 plus e to the 3/4 plus e to the 5/4 plus e to the 7/4, and then if I add up all those ones, I have plus 4. Of course, at the previous step, I could have just typed this in my calculator, but in this situation, if I type it into my calculator, and I paused and typed that into my calculator, I got 8.322985533. So I just added all of those, added the 4, then divided everything by 2. So this represents the sum of the area using 4 rectangles on the interval from 0 to 2. So the width of each interval was 1/2, that light blue 1/2 there, times those y values, the outputs. And if I calculate my exact integral, which again, we're building towards that knowledge, but the exact integral, the exact area of that is 8.3890561. So this value is pretty close. It's slightly smaller, but it's a pretty good estimation. So I found the area of this curve here using the midpoint sums. If you want to give yourself extra challenge, you could go through and find your upper sums, and your upper sums would be 10.11887413. Okay, so that would be your upper sum. So I encourage you to take a minute, see if you can, and create this same area equation, but with different output or height values. And make sure that you can do this problem and get 10.1188.